We welcome Dr. Vijay Kumar Krishnasamy, who completed his BE, ME, and PhD from NIT Trichy, followed by postdoctoral research at Nanyang Technological University, Singapore, and is currently Associate Professor at IIT DM, Kanchipuram. His research interests include smart grids, IoT, power electronics, renewable energy systems, and machine learning applications in energy systems. Sir, the session is yours.
Yeah, good evening to one and all. It's my great pleasure to be part of this Atal FTP program. It's my great pleasure to share my insights on green mobility for public transportation. When we talk about green mobility, so just we need to go why we need a EV for at present scenario. So when we talk about EV, just we can talk about environmental pollution and everything. So at the same time, we can able to reduce the fossil fuel usage as compared from the present level. At the same time, just we can greenhouse gas emissions also can be reduced by moving towards that green mobility. So when we talk about the green mobility, people might ask that whether we can consider only the battery operated vehicle or fuel cell vehicles. So we can consider both of them, that the battery operated vehicle as well as fuel cell vehicles also we can consider as a consider for green mobility. So here, if you look at that, the air quality in Indian cities. So these are in alarming rate. So in Delhi, if you look at that, 22 cities in India are most polluted. So in that Delhi, if we look into it, almost 41% of that nitrogen oxide emissions are due to of the vehicles. So for reducing this nitrogen oxide emissions as well as PM 2.5, so we are moving towards that electric vehicles. So here, when we look at that carbon emissions, at the same time in the y-axis, we can take that technological advancements. So if you look at that, how we can have the potential to reduce the carbon. So here, by having that advancement in IC engines, we can able to reduce only up to 15% of the carbon. But when we move into that natural gas, or if you are going for alternative fuels, so there is a possibility to reduce that carbon emissions from 10 to 30%. At the same time, if you are talking about hybrid electric vehicles, not fully electric vehicle, we can consider the hybrid electric vehicle. So in this hybrid electric vehicle, we can have the potential of to reduce 30 to 40% of that carbon emission. So if we move into that fully electric vehicle, or we can say that fuel cell based electric vehicles, that we are going to use hydrogen as a fuel. So in these cases, there is a possibility to reduce the carbon emissions from 50 to 100% range. So here, these vehicles, the hybrid vehicles, or fully, battery operated vehicles, or we can talk about hydrogen based vehicles. These are the electrification of the transportation sector. So when we talk about electrification of the transportation sector, we are having the huge number of options. Not only that, electrifying the passenger vehicles, we can able to electrify that commercial vehicles, and whenever we are using the vehicles for goods movement in local as well as in the commercial applications, we can able to electrify it. So by doing this kind of electrification, we can able to reduce the carbon emissions. At the same time, even people are looking for electrification of we can say that ships. So ships also normally just we are using for movement of the goods. So Ministry of Shipping also they are promoting that electrification of that ships in India also. Even recently, you might have heard that from Ministry of Earth, you got some call for so net zero marine systems. So in this every transportation sector, if we can see there is a possibility to reduce the carbon emissions. So why we are moving towards to reduce the carbon emissions means because of the pollution. So even if you look at that, because of the pollution, the number of deaths are keep on increasing in India as compared to other neighboring countries as well as some developed countries. Even you can look at that number of deaths in India is almost 2.5 millions of people dying because of the pollution. So yeah, this is very high rate as compared to even our neighboring countries like Pakistan and all. Yes, I think some message from the audience side. Let me check it out. Yeah, any questions or yeah, it's not moving. Yeah, sure. Someone is trying to join, I guess. Yeah. So here, if you look at that number of deaths, it's happening in India is in a higher rate as compared to even developed countries and developing nations. So that's what we are looking for, that electrification of that transportation sector. So why we need electric vehicles? Of course, to reduce that global temperature, and so if you want to reduce the global temperature, then the pollution caused by this fossil fuel should be reduced. So that if we move forward to implementation of that electrification of the transportation sector, we can able to reduce that fossil fuel usage. At the same time, even if you look into that renewable energy sector, it's a very growing sector, and even in India, there is a huge potential of wind and solar power or solar energy generation. So that's what even in India we are having the ministry called Ministry of New Renewable Energy. So they are also come up with the frameworks and guidelines to increase the installed capacity of this wind and photovoltaic systems. So India proposed to have 175 gigawatt of that renewable energy capacity by 2025. So almost we have reached almost 168 or 171 gigawatt of the installed capacity. Even just we are having some few more gigawatts to reach this target. So why we are saying this advancement in renewable energy means instead of the fossil fuel, just we are using renewable energy sources to generate the power and supply to this transportation sector. Here, when we talk about electric vehicles, so here there is no fuel and no emission. So we are not using any kind of fuels to burn it, so that the carbon emissions by these vehicles also is not there. At the same time, if we are talking about that electric vehicles are very cheaper to run as compared to IC engines, because just you can charge your electric vehicle in a single charge. You can able to drive for 400 to 500 kilometers range. So only just we have to pay 100 or 120 rupees for a full charge. So it's very cheaper to run. At the same time, if you are using your renewable energy sources for charging your vehicles, so almost you are going to nullify the charging cost. So there is no charging cost, because whatever the power you are using for charging your batteries in the electric vehicle, that can come from the renewable energy sources. So here, the bottleneck is a wide range of speed, but now it has been improved. So we are having the wide range of speed from the electric vehicles. So almost you can, in a single charge, you can able to run 400 to 500 kilometers based on the variants. So at the same time, if you talk about the health benefits, of course, because of this implementation of this green mobility, or we can say that electrification of the transportation sector, we can able to get a lot of health benefits. So that's very much required as compared to the bills, right? So that's what just we can achieve by having the electric vehicle technologies. At the same time, here as compared to the IC engines, here here in electric vehicles, the moving parts are less. So if even if you are saying some moving parts are less, then the noise coming from the vehicle also it's quite low. So here at the same time, when we talk about the maintenance, so the maintenance is very easy. At the same time, the maintenance cost also is less as compared to the IC engine, because in IC engine you need some expert to repair your IC engines, but here it's not a case. So it's very cheap to maintain. At the same time, by having this all electric vehicles, in an electrical power system perspective, we talk about, so we can able to have a lot of services, ancillary services. At the same time, that by aggregation of this, EVs can provide the reactive power support to the distribution systems by monitoring that EV charging. You can able to track the out of the renewable energy sources, and you can do that load balance. So load balance means once you can able to aggregate all the EVs, so that EVs can have a very good capacity. So that capacity can be useful for energy management system in a electrical grid. So the safety improvements, it's day by day, it's increasing. So when we look at that electric vehicle policy roadmap in India, so in 2010, the Indian government come up with a strategy to reward some subsidies to the OEMs with a budget of we can say 950 billion. So because of this, there are a lot of OEMs they have started to promote the EVs. But in 2012, if you look into it, they have scrapped that incentives to the OEMs. So there is a huge dip in the sales of that electric vehicles. That too we can say is a 70%. So because the government has scrapped this, we can say subsidies to this OEMs, then then government realized, then they have come up with a new plan called National Electric Mobility Mission in National Electric Mobility Mission Plan 2020 in 2013. So with a period of we can say it's 7 years. So again the EV has picked up. So then we can say in 2015 again they have come up with the same one scheme. So that is again for 4 years by Department of Heavy Industries with a budget of 5.29 billion. Then again, in 2019, they have come up with the same two for another 4 years with a budget of we can say 100 billion rupees. At the same time, they have given some tax rebate to the EVs as well as the chargers. So that's what EV had picked up in the year of 2019. Now we are in the good shape of that EV technology. So all the OEMs they have entered into that the green mobility sector. So here, if we talk about the sales in India, the sales, if you look at that as compared to that four-wheelers and goods vehicle, the three-wheelers sales were very good in the beginning. The reason is, even that auto rickshaws or, some public transportations. They have come up with that electric vehicles in earlier cases. Then the two-wheelers also is significantly increased the sale, increase in sales. So yes, increase in sales. So at the same time, if you look at that, the four-wheelers are not that much good in the sales as compared to the two-wheelers and three-wheelers. But nowadays, the four-wheelers, the passenger vehicles also are moving very good. And the goods vehicles are, if you talk about the commercial vehicles like electric buses, electric trucks, even the electrification of that railways and all, we can say it's growing. Growing means we can say in the goods vehicle or commercial vehicles, people are using that fuel cell based vehicles. So because you'll get a huge space to accommodate that hydrogen cylinders and all. So in that way, that four wheelers, that electric buses, trucks, and all, it's getting popular. So when we talk about the EV components industry growth, as we talk about the equity perspective, the electric motors, share is almost, we can say, is 1/3 of that market. Electric motors is going to, going to supply to the automobile industry. So that even if you look at that market share, almost it's $1.23 billion US. So at the same time, the batteries, not only the batteries for electric vehicles, even if you look at the electric vehicles, we can say in 2025 to 2030, the 67% of the battery market share is for 67% of the market share in the automobile sector. So the same case for power electronic converters and devices, almost we are having $1.47 billion market. So in that, we can say because of the semiconductor manufacturing, the Indian government also is focusing towards that development of this power electronic devices. Then charging stations, again, the charging stations is the application of the power electronic converters. Once you can design and fabricate the converters, that can be used to charge the electric vehicles, whether it's in a public transport or you can say it's in the passenger vehicle sector. So when we look at that infrastructure perspective, so for if I want to deploy the 100% EV, you cannot able to do it. Even if you assume that you are going to make 30% of the vehicles as a EV in 2030, so the demand, you can look at that, almost we need 16,000 crore units of the electrical energy. So that demand is going to increase once you can have only 30% of the vehicles as an electric vehicle. So for that itself, you need the 16,000 crore units. So how we are going to meet out this demand? That's a big question mark, because without having the very good charging infrastructure, you cannot adapt the EV in a full-fledged way. So even today, if you look at that, just we need, I mean, we are having 1,38,910 crore units of power generated, and the demand, you can see 1,39,000 odd, crore units. Almost now itself, we are having the shortfall of 856 crore units. We can assume that 30% of the vehicle going to be electric. Then in addition, we record that 16,000 crore units of the electrical power. So we cannot able to meet out suddenly of this demand. So for that, you need to go with that you need a lot of capital to deploy that new power plants and all. So what is the impact of this electricity demand and grid capacity? Of course, the government also is coming forward to have that new power plants. So to meet out this demand, however, the not only this electric vehicle is growing, other industrial sector also it's growing parallelly. So they're not able to meet out these demands. So for that, the the utility companies, they have come up with that demand side management by having the time of use tariff. So at present, if you look at that, we are having the fixed tariff. So irrespective of we can say that irrespective of number of units you are consuming, just we have to pay. We are not having any time of use. Only based on the units we are paying it. Whether you are consuming 300 unit, 500 unit, whenever you want, you can consume it. Based on the number of units you are paying the electricity bill. But in future, there is a chance to get in the time of use tariff. So, like the best example of the time of use tariff is our Uber and Ola. So whenever the demand is higher, the price is higher. So when the demand is low, then just you can get that vehicle at the low tariff. The same way in that electricity also, in the time of use tariff, whenever the demand is higher, then the electric utility companies, they charge you heavily. So during the off-peak hours, that means whenever there is no demand, that time you will get the electricity at a cheaper price. So by implementing that time of use tariff, you can able to change the consumer behavior of consuming the we can say the electricity. So whenever the electricity price is higher, then that time I may not operate all non-critical loads. So all the non-critical loads I can shift it to that non-peak hours. So in that way, I can reduce my electricity bill, right? So now the question is how we can implement the time of use tariff, because I cannot sit in my home to watch the electricity bill, and I cannot control my home appliances. So for that, we need some automated system. So that's what the IoT also plays a huge role in the smart homes or smart buildings. So your system can will fetch the tariff of your electricity. Based on that, that will schedule the loads. Even if your electricity bill is less, that time just all non-critical loads will be switched on when the electricity price is higher at the peak hours. Then your system can cut off all the non-critical loads. So that in that way is a win-win for the consumers as well as the utilities. The reason is the consumers, I can able to reduce my electricity bill. For the utilities, they can they need not to invest much capital for installing the new power plants. So in that way, the DSM, the utilities, promoting this DSM activities. So here, according to that Niti Aayog, in 2040, the energy consumption will be double. So even if you are saying energy consumption will be double, the GDP of our country also can go higher. So that is a benefit for the even for the nation. So in that way, just we have to increase that electric power generation. So when we come into that electric vehicles and IC engine based vehicles, so here if you are using that natural gas, coal, nuclear or biomass to generate the power, so that power can be used to drive the vehicles. So that vehicles will be called as electric vehicles. And earlier we have used the oil and natural gas to drive our vehicles, that involves IC engines. So that IC engines, we are having some advanced, advanced technologies like Bharat 4, Bharat 5, Bharat 6 and all. So based on that, you can able to reduce the carbon emissions. In addition, instead of generating the power from this conventional resources, you can go with that non-conventional resources like wind photovoltaic system. You can generate the power. That power can be used to charge the batteries. So in that way, you can able to nullify the charging cost of your green mobility. At the same time, we can classify this hydrogen-based vehicles also as electric vehicles or green vehicles. The reason is the output from the fuel cells are the power and the water. So that's what we can say is a clean and green energy resource, the hydrogen-based fuel cell vehicles. So when we compare to that EV and IC engines, just you have to you want to compare tank to wheel efficiency and well to wheel efficiency. So these two terms are very important when we are comparing the IC engine and EVs. So in most of the cases, they will compare with the tank to wheels efficiency. So when we compare the tank to wheel efficiency, the battery operated vehicles will give the very good numbers. Even if you look at that top one, so here we are getting a 72% efficiency, then fuel cell vehicle 40% and IC engine 16. So by looking at that, so which one is very good efficiency out of these three? Out of these three, which one is high efficient? Whether it's a battery operated vehicle or it's a fuel cell vehicle or IC engines. So it's a battery operated vehicle. So just you can get the 72%. And fuel cell vehicles, the 40%. The reason is the fuel cells also having the thermodynamic efficiency. The conversion efficiency of the fuel cell vehicles are 55% in the fuel cell. And again, you'll get some losses in the motor drive. On the wheels, you'll get only 40%. So here, battery operated vehicles, you'll get it get 98% in the battery terminals. Then you'll have some losses in the electric drive. Then 72% you'll get it on the wheels. So in the IC engine, again, just you can say 100%. So because of thermodynamic efficiency of the IC engine, you'll get only 20% efficiency. Again, 3% will go as a loss in your drive line. Then on wheels, you'll get only 16%. So by comparing all these three vehicles, we can say that battery operated vehicles are very efficient. But that's not a case. So we cannot compare in that way, and we can't say that battery operated vehicles are more efficient than that IC engine or fuel cell electric vehicles. So now we have another term called well to wheel efficiency. So this one is a very important term when we assess that EV compared to the IC engine. So look at here and you can tell me which one is efficient now. The efficiency of your battery operated vehicle is 18%, right? But here IC engines is a 13%. So here I'm considering the efficiency of your vehicles from well to wheel. So well means where you are taking the crude oil. So that crude oil going to the oil refinery. So that is 95% efficient. Then that refined oil go to the power generation thermal power plants. There just you will get 36%. Then transmission you are getting some losses. So 34. Then battery charging 35. And in the drive line and everything that loss goes, then on the wheels you'll get 18% in the battery operated vehicle. The same thing is happening in that IC engine also, because for IC engine you need a petrol or diesel. So that it's coming from the oil refineries. So there the efficiency is 87 and filling stations 83. So there are a lot of losses in the filling stations. Then on just you can fill up the petrol on your tank and you drive it on a wheel, you'll get only 13%, right? So if we compare these two, only we have the difference of 5%. So for this 5% only, every government, they're promoting the electric vehicle. So even this 5% is a huge number. So just we'll get the very good savings in terms of fossil fuels as well as the capital you are deploying for thermal power plants and IC engine based vehicles. So now when we come into the electric vehicles, what are the different, components we are using? Just we can say permanent magnet motors, or you can say BLDC motors for two-wheelers, and even induction machines also employing in passenger vehicles. So in a permanent, we can say in a passenger vehicles, permanent magnet and induction motors are very popular choices. So here, most of the EVs they are using these two motors. Here, if you look at that permanent magnet motors, so permanent magnet motor having the high efficiency because of permanent magnets are permanent magnets are used to excite that machine, and you'll get the high torque and short constant power range. So those are the advantages for permanent magnet motor. When we come into the induction motor drives, so here it's a very simple and robust, but you are having a very less efficiency than your permanent magnet motors. So that's what most of the commercial vehicles, they are commercial and passenger vehicles, four-wheelers, they are using their permanent magnet motors. And now switched reluctance motors also using in that electric vehicles, because it's having the very high speed. So whenever you need a high speed in a shorter duration, then this switched reluctance motors are the very good option. So now when we come into that classification of your electric vehicles, so electric vehicles, when you talk about, you need to start with that hybrid vehicles. So hybrid vehicles are getting popular from the conventional IC engines, because in IC, even if you talk about the conventional IC engines, you are having a 100% internal combustion engines. So mild and micro hybrid, you can say your engine 80% and 20% of your electrical parts. So battery and electric motor. In the mild hybrid, you can say 50-50. So 50% IC engine and 50% the electric vehicle. So in a fully electric vehicle, you can say more than 80% of the parts are from electrical side. So that we can say is the fully hybrid vehicles, or we can say is the battery operated vehicles. Whenever you are not having the IC engine part. So in this, you can able to connect series and parallel. So that series and parallel also can have the impact on the driving efficiency, right? So in that way, these are the models they are using this parallel series, hybridization. When we come into the energy loss in the city driving, so if you look at that, the urban drive cycle, so if you're having 100% fuel tank, then the engine, your IC engine you're having, so the output of the IC engine is 60%, and in the drive line you're having the 3% loss, and 13% you're 13% of the energy you're having on the wheels. So on the wheels, again, you can classify the energy consumed in the vehicle. So because of the aerodynamics, you can have 3% rolling, you'll lose 4%. When you're applying the braking, 6% will go. So total, if you calculate, then it's a 13%. In addition, the driveline losses also is a 3%, and engine losses 76% in the city driving. So standby and engine losses, as well as here also, you are having only 13%. So here, if you look at that highway driving, so there is no standby losses because you are driving your vehicle on the highway. So engine losses, of course, it happened, and 23% you will get it on the drive line. So here also, you are having a 4% loss. So on the output, we can look at that 19% you'll have it on the wheels. So in that in the highway driving, your car will be in higher speed. So the aero it's a 10%, rolling is a 7%, most of the time will not apply the brakes during the highway driving. So it's a 2% it's going for the braking. So now you can analyze it where you can apply the hybridization. So what type of hybridization is required, or whether you can able to do the full electric vehicle by looking at that. So standby, you want to reduce the standby efficiency, standby losses, then you can go with the micro or mild hybrid. So that we can able to reduce the standby time. Even now, the Activa itself, we are having this kind of hybridization, so that we can reduce the standby 8%. And engine losses, if you want to do, if you want to reduce it, then there is no other way. So just you have to go with the electric vehicles. That means full electric vehicle by replacing the IC engine. And driveline losses, we can able to have it. So there is no other option. But in the vehicle related efficiency, if you look at that, if you're going with a mild or micro, again, just we can able to save that 6% of the braking losses by using the regenerative braking method. So that and all is possible with the electric vehicles. So this is a pictorial representation of that well-to-wheel efficiency. So if you look at that on a wheel, you'll get 23% in the IC engine, and sorry, in a battery operated vehicle. So in an IC engine, if you look at that, 13%. So almost 5, you can say it's a 5 to 10% is the difference. So even the 5 to 10% difference is a huge number. That's what, every nation, they are focusing on the electric vehicles. Now, just we can talk about electric vehicles. So electric vehicles, in whether it's in public transportation or in the passenger vehicle sector. So how this electric vehicles plays the role in a electrical grid, or you can say in the smart grid. So why now I'm calling a smart grid? Any reason to call our grid as a smart grid? Is there any kind of new entity as a smart grid, or it's an existing grid? So if you look at that smart grid, so just we are adding the features into it, right? So if you're adding the features into the existing grid, so that grid you can call it as a smart grid. You can say that by adding the features, just you are adding the intelligence to the system. So here also, as like our any other system, whether it's in a manufacturing, or if you talk about the banking, or it's a insurance sector, everywhere just we are adding, just we are integrating this, AI or ML, artificial intelligence or machine learning models. So here, if you are talking about the AI, normally AI-related controllers are employed to enhance the dynamic performance of the system. So whenever you need the precise model of your electrical, precise model of any component in your electrical system, the ML models will be really helpful to model, and it can do the different case studies. So here, if we talk about the smart grid, so earlier when we talk about the power grid, so it's a unidirectional power. It can generate the power, and it can transmit it, and it can distribute to your consumers. But now, just every component of your electrical grid come up with the communication. So if you are come up with the communication in each and every part of your grid, then it will be very easy for you to communicate with the different devices in the system, so that that can able to so in that way you can able to control each and every device in the system. At the same time, by you can able to monitor monitor the each component in the system, right? So that under it's possible. So now earlier you can say is a generation, transmission, and distribution, but nowadays not like that. Just we are having the green power generation sources that also integrated into the distribution network. So at the same time, in the load side, if you look at that in the yellow color or orange, Then factories, the factories are also it's automated. So that's what people are talking about industry 4.0 and 5.0. And homes, that means residential buildings, commercial buildings. If you look at that, we are leveraging the lot of technologies. That means we can leverage that IoT, AI, and ML, so that we can able to have the precise model, as well as we can able to have the precise control over the components. So when how we can realize means in the smartphones. So earlier days, if I want to do that air conditioning of my room, then I can say you can give me this much tonnage of the AC. But now not like that. In between, then we have looked into that, B ratings. So based on the B ratings, you can buy the air conditioners. Then later now, so what are the how we can buy the air conditioners for your home? Even you might have seen that lot of advertisements, right? Inverter based air conditioners, and even now people are talking about smart inverters, right? So sorry, smart refrigerators and air conditioners. So what is a smart refrigerators and air conditioners? So when we talk about the smart refrigerators and air conditioners, we can able to connect that air conditioner and refrigerator with your home, home Wi-Fi. So if you connect it to the home Wi-Fi, then you can able to control these air conditioners and refrigerators remotely. So you need not to be in a home to control this, appliances. So just you can have the control over the devices wherever you are. At the same time, you can put a lot of analytics into the system. So if you're putting a lot of analytics into the system, your GUI itself can estimate the requirement of that energy for the next month, and how much you need to pay to that electricity board. Every information will be available. So that's what the analytics also come into the place, and IoT come into the place. When ML models also plays the huge role to model your electrical system and predict a lot of parameters in the system. So when we talk about the commercial buildings, so the commercial buildings also is getting popular nowadays. The reason is just energy conservative measures in the buildings. Now people are talking about green energy buildings, or we can talk about net zero buildings. So net zero buildings means you can say how we can able to reduce that energy consumption of the buildings. At the same time, how we can come up with that new technologies. That new technologies can save the electrical energy. So in that way, the buildings are also coming up with IoT based devices. In addition, in the renewable energy side, if you look into that, how we can able to mix up that various renewable energy sources and batteries and all. So that also is coming under the smart cities or smart building side. And even the EVs also is getting popular. Now the question is how we can utilize this electric vehicles for providing the ancillary services to the grid. So when we talk about the electric vehicles at present, just we can consider as a load. Even we are not considering this, electric vehicles as a storage device. So whenever the power, we can say that whenever that need to charge your electric vehicle, just you need to plug into it, and you have to charge your electric vehicles. So then we can drain the battery, then again you can charge it. So we are not at all remain connected these electric vehicles with the grid. So in that case, if you see that the grid burden will increase. So once you can able to remain connected, then you can able to give ancillary support to your grid. That means by aggregating all these EVs, you'll get a very good battery capacity. So now I'm saying aggregation of this electric vehicles, but in a real time, aggregation of this electric vehicle is really a challenging task. So you need a very good precise ML models to aggregate all the EVs in your network. So by saying that, aggregate means simply I cannot go and aggregate. So your electric vehicle remain connected to the power grid as well as remain connected with the communication network. Then only can able to aggregate. So that and all, it's possible in the smart city, or we can say in the smart grid architecture. So once you can aggregate, then you'll get a very good battery capacity. So this battery capacity can provide all the ancillary services required by this distribution system, as well as that services required by this loads. We can say that residential buildings, smart buildings, and factories, right? So now aggregation. So how we can aggregate? So with the help of that, AI models or the machine learning models, we can able to aggregate this EV, because aggregation at the same time, just you can use time of use tariff for charging. So whenever the electricity price is higher, then your EV might disconnect it. Whenever during off-peak hours, your electricity price is lower. That time your EV will be connected for charging, right? So in that way, you need to develop the strategies to cater to this transportation sector efficiently. So now, if you look at that role of electric vehicles in smart grid, so whether it's a public transportation or your personal vehicles, how we can connect to the network. So if you're connecting to the network, then there is a concept called vehicle to grid, grid to vehicle, and that's possible. So vehicle to grid means you are discharging your battery. Now grid to vehicle means you are charging your battery. So that's what we are saying is a vehicle to grid and grid to vehicle. So for that, you must have the server, right? So that management server. So you must have that strategy to, schedule your vehicles for charging and discharging, right? So in addition, not only that, your vehicle will be connected electrically to your, distribution network. Also, you need the communication line between your utilities and your electric vehicle. At the same time, in a home also, just you are having the Wi-Fi router, so that you can connect your vehicle with a Wi-Fi router, so that I can get all the information, all the vehicle related information. So once I'm having the vehicle related information, that information can be used to schedule the charging and discharging. At the same time, I can get to know all the information. So how much SOC the particular EV is having, so how much time I can run, whether the travel is scheduled today or not. So those informations will be taken care by the communication network. So along the power network, you also require the communication network, so that can provide the that will provide the smartness into the system. So if you're not having any communication line and communication among the various devices, then it's very, very tough to make your system smarter or intelligent. So now when we talk about vehicle to grid technology, so just we are having the framework for vehicle to grid technology. So in this, the aggregators plays a huge role, because we need to aggregate all the vehicles and we need to assess the various information from them, and you have to give it to the service provider. That service provider will give you the reference signal, whether your charger can charge your vehicle or discharge your vehicle. So all the things will be comes under the vehicle to grid framework. At the same time, if you are talking about vehicle to grid technology, you can able to reduce the peak hours. That means we can able to shift loads from peak hours to off peak hours, so that we can able to make that demand curve flat. So even if you are saying the demand curve is flat, then scheduling of your generation or the scheduling of the loads and all is easy in the energy management system. So that's what this one we can say is a peak saving or valley filling, or some other tech. Even we can say some other techniques. So here, as we say, earlier we have discussed about vital to grid and grid to vital. Now people are, even in the vehicle to grid and the grid to vital, how we can use your electric vehicle in a home means we can use your electric vehicle as a UPS, uninterrupted power supply. So whenever the power goes off, then your electric vehicle come into the picture. So that will act as a, your inverter or UPS to power up your home. So this and all is possible. So that's what people are now talking about. Earlier they are talking about V2G, G2V. Now people are talking about vehicle to home or vehicle to building. So still it's in the nascent stage. So in future there is a possibility that you can use your electric vehicle for reliable power supply to your home or offices. So this and all is very safe, reliable, and we can say is cost effective technologies. So vehicle to building or vehicle to home. In addition, if you look at that, for that your inverters be smarter enough. So if you're using that unidirectional inverters, you cannot able to implement these technologies or strategies. So if your vehicle, your charger is smarter, then just we can say you can able to do that bidirectional power flow. So by doing the bidirectional power flow, you can able to implement the V2G and G2V concepts. Excuse me. Yes. The next, if you look at that, outage scenario of your grid. So even if your grid is out, then you will not get any power to charge your electric vehicles. So in that case, just we can combine with a PV system. Then you can see that the resiliency. That means if you're having the solar system EV, then the number of days is keep on increasing. So this will give some incremental value to the stationary storage system for long-term outage scenarios. So in this case, we can say the investment cost is higher than the earlier system because you're having the photovoltaic system as well as the EVs. So earlier days we have talk about V2G, G2V, but not nowadays people are talking about vehicle to X. You can vehicle to grid, vehicle to load, or you can say it's a vehicle to vehicle or vehicle to home, right? So if you're having the EV, then you can use that battery for any kind of application. So that is the main benefits of the vehicle to X. So we can you can participate in the electricity market, as well as you can able to decrease the investment for the new power plants in terms of utility perspective. Then you can able to generate a lot of revenues. So the business models also it's available with vehicle to X. So at the same time, you can participate in the demand side management. You can able to reduce the peak hour demands. So that will be helpful for reducing your electricity bill. And if we talk about vehicle to X, then you can able to connect your vehicle to the other vehicle, and you can able to discharge your battery to charge them, so that the other EVs also get benefit out of it. And even if you're having the EV, you can able to power up the remote size. So that also it's a possible with the electric vehicles. And at the same time, if you are having all the communication protocols and your EVs remain connected to the communication network, then you can go with a lot of vehicle management services like your parking management, or you can say that service management of your vehicles. Everything is possible. At the same time, if you look at the utility perspective, they can able to enhance grid stability, reliability, as well as security. At the same time, you can able to integrate all your renewable and green energy sources to utilize at maximum. So that means if you are connecting your wind and photovoltaic system, you can use as much as possible and you can reduce the grid burden. At the same time, if you are having your vehicle, you'll have the higher independence. At the same time, you can provide the power to all the remote sites during emergency or your lesser period. So for that, when we talk about that green mobility or electric vehicles, we need to go with the smart charger. So when we are increasing that advanced technologies, that flexibility is also it's higher. But if you are not having the smartness in your technology, then you can say the flexibility also it's be less, right? So in that way, if you're going with that smart chargers, the flexibilities are higher. So now, just you can see that by integrating this renewable energy systems, you can see that the cost of that EV charging is coming down. So at the same time, if you look at that V2G, so V2G, then the marginal cost, average short run marginal cost, if you look at that, it's going very down, right? Excuse me. So at the same time, if you look at that CO2 emissions, CO2 emissions also is coming down. So by integrating that photovoltaic systems in the EV charging stations can give huge benefit. So not only the PV, you can compare in long-term perspective. You're having the wind energy conversion systems as well as the photovoltaic systems. Then if you look at that, the peak loads are greatly decreasing in both the cases, not only the EV, not only on the PV, on the wind also, that peak load is coming down. At the same time, if you look at that, carbon emissions, the carbon emissions also is coming down, depending upon the capacity of your wind or photovoltaic system installation. Now we can see that evolution of EV flexibility along with that renewable energy generation by 2030 and 2050. So almost you can say that EV penetration, till today that EV penetration is lower, but day by day it's keep on increasing. So that's what, even if you look at that, some of the European countries, they have come up with that policy that no more fossil fuel based vehicles. In Netherlands, they are planning in 2027 and 20, in between 2025 and 2027. Then France and UK in 2040, they are planning no fossil fuel based cars. So China and Japan, if you see, 2050, they are going to be fully electric. So if you look at that, the battery requirements at present are very small batteries we are employing. So in future, there is a chance to increase the increase the battery size for your electric vehicles, so that we can able to enhance the driving range, 600 to 1,000 kilometers per single charge. At the same time, infrastructure charging stations. So at present, we are not having any kind of bidirectional, chargers. In future, there is a chance to get into the bidirectional chargers. So once you are having the bidirectional chargers, you can able to use your EV for any application. So whether it's a V2 home, V2 buildings, or you can say V2 loads or V2 anything, we can say, right? Even that most of the people, 90% of the time, we are parking at our, parking at our home or in our workplace. But if you're having the hub charging more, then you can able to reduce the parking time. And the fast charger also is coming down. So within a few minutes, you can able to charge your entire, electric vehicles, So now I'm skipping this configuration of your, electric vehicles. I may talk about more on that, how we can able to aggregate the, aggregation of that electric vehicles. Before going to that, just I want to show you some of the power electronic converter configurations which we are using for charging the EVs, whether it's passenger vehicles or you can talk about the commercial vehicles. So people are even we are also it's working on different power electronic converter topologies for charging your EV. So in that we are implementing a lot of artificial intelligence based controllers to control the converters. So in that way, you can able to enhance the dynamic performance of your chargers. So here you can say two types of power conversion. So AC to DC, then DC to DC converters. Then that DC to DC converters can charge your batteries. So here we can say is high reliability and high efficiency you can able to achieve in this power conversion stages. So here I want to talk on that fuel cell vehicles. So before going to the fuel cell vehicles, just we must know that what is green hydrogen and blue hydrogen. So when we are saying it's a blue hydrogen, so the blue hydrogen is segregated from the natural gas. That means just we can draw the natural gas from the seashores and send it to the steam reforming. Then it can fabricate the hydrogen and capture that carbon dioxide. So that hydrogen can be used in all industries. But nowadays people are talking about the green hydrogen. The green hydrogen means it's nothing. So here also just we are using the electricity for generating the hydrogen with the help of that electrolyzers. But here the electricity which you are using in the electrolyzers, you are getting from the renewable power generation sources. So how we are getting the renewable power generation sources means in most of the locations, we are not having the sufficient infrastructure to feed the renewable energy, or we can say it's the wind power or photovoltaic power. So in that cases, instead of installing your wind turbine or photovoltaic power generation plants, you can use that energy to produce the hydrogen with the help of electrolyzers. So that the electricity required by this electrolyzer come from the renewable energy sources. And when in the electrolyzer process, that hydrogen is the output as well as the oxygen. So there is no harmful gases coming out of this electrolyzer. So that's what the hydrogen produced from the electrolyzer is called green hydrogen, right? So this green hydrogen used in the many applications in the industries. So whether we can talk about chemical and pharmaceutical companies, they are using this hydrogen. And if you look at that, fertilizer companies, so that synthetic ammonia can be produced from the hydrogen. So that synthetic ammonia can be used in all the fertilizer companies. So there we are using the hydrogen, and again the same hydrogen we can use it in the fuel cells to generate the electricity. That electricity can used for driving your vehicles. At the same time, the fuel cells also used to power up the homes in the remote location. So the only problem with the hydrogen economy is to produce the hydrogen as well as the storage. The storage is the main part in the green hydrogen economy. So even nowadays, people are working on that storage technologies to store the hydrogen. Even in India, the union government also coming up with a lot of budget allocation for the green hydrogen production. So almost they are having 5 million metric ton of green hydrogen production with a 60 to 100 gigawatt electrolyzer capacity. So in addition, they are having the target of 125 gigawatt of the renewable energy capacity. So with a budget of 1 lakh, 19,000 crores. So in that we can able to save at least 1 lakh crores for imports. So at the same time, not only in the monetary benefits, you can able to reduce the carbon emissions also, right? So that also is possible. On top of it, you can able to create a lot of job opportunities in the area of green hydrogen. So even if you look at that green hydrogen and fuel cell vehicles, so just we can say the hydrogen storage system. That hydrogen storage used to store the hydrogen from green hydrogen from the renewable energy sources and blue hydrogen from the we can say from the natural gas. So that also can be stored in the hydrogen storage system. Then that hydrogen can be used to provide that supply to your fuel cell vehicles. At the same time, the whenever the industries require the hydrogen, that also can be supplied to this fertilizer companies and pharma companies. So there we can get the efficient use of the hydrogen. So when we come into that fuel cell electric vehicles, so the fuel cell electric vehicles are having that different power converter topologies. You can use it to charge your to drive your motor. And here we are having the fuel cell stack and hydrogen tank to supply the hydrogen to the fuel cells. So the same converters also you can use it here. Only thing is that here you are getting the DC power from the fuel cell stack. So that we have to condition and we have to drive your vehicles. Right. So I stop at this point. If you have any clarifications or doubt, I'll be happy to answer it. So now I told you the aggregation of the electric vehicles. So the aggregation of the electric vehicle is not that easy actually. So here you have to use a lot of AI techniques to aggregate it. Even you must know the various parameters of that electric vehicle. So you must know the state of charge, DOD, and how much time you have traveled and which time you are going to use your vehicle and how much distance you are planning to travel. So whether you are having that sufficient energy in the battery, everything you have to consider. So for that, you have to leverage that AI to model your system. So that's what nowadays we are doing, aggregation of all the electric vehicles to create some energy storage capacity. So that energy storage capacity can provide the ancillary services to our smart grid, right? So for aggregation of these electric vehicles, just we are using that various machine learning models. So that machine learning models can give you the very good estimation of that battery storage capacity. At the same time, you can have the data. So that data can be used to analyze the analyze that vehicles driving range as well as that driving usage and all. So That's what we can say. At the same time, people are also leveraging this AI models for smart parking systems as well as that public transportation and everything, right? So just by leveraging these technologies, we can able to make our transportation sector green, cleaner, as well as the reliable. So with this final note, I'd like to stop at this point. If you're having any specific questions, I'll be happy to answer questions. Thank you.
Participants, if you have any doubts, you can ask.
Yes, I think 115 participants. Any questions or?
You can unmute the microphone and can ask the questions.
Yeah, thank you, ma'am. Sorry for the glitches. Actually, I'm having a throat pain today.
So no problems.
Yeah.
So good evening. I'm Shivakumar from Tyagaraja College of Engineering, research scholar. Sir,
Yeah,
I have
please.
one doubt, sir.
Yeah, please.
Sir, without controller, we can control the charging devices in EV, sir?
Yeah, we can able to, because normally no, when you're having the EV chargers, so you are having the multiple controllers. So multiple controllers to take care of the multiple functions. So on top of it, you are having the another microcontroller, very powerful controller to coordinate this control strategies of each block. So we'll not use only the single microcontroller to take care of each and every part. Even if you have the DC to DC converter, you'll have one microcontroller to generate the pulses. And for monitoring, you're having the another microcontroller. And for coordinating with the other charging blocks, just charging blocks, or you can say any other control aspects in the vehicle related control aspects also can be coordinated. For that, you'll use the different microcontrollers.
Okay, sir. Rather than this, we can use a single controller for all.
No,
PLCs,
because of
techniques,
the
everything.
reliability. So once that controller fails, then your entire system will be halted.
Okay.
Right. So that's what we can't use the single microcontroller to control each and every part of the vehicle.
Okay, sir. Okay. Okay, sir. Thank you so much, sir.
Yeah, welcome.
Good evening, sir.
Yeah, good evening, sir.
So what are the recent researches going on to reduce the cost of the initial cost of the e-vehicles, particularly the costs occurring due to the presence of batteries?
Yes, that's what for reducing the cost. For example, if you are increasing the speed range, the cost also will increase. The reason is you need to go with the higher capacity of the batteries. So nowadays, people are working on that different batteries technologies to come with the high energy density batteries, kind of flow batteries. At the same time, when we are talking about the commercial vehicles to enhance the speed range, they have come up with the hybridization of that battery and fuel cell technologies. So in that way, you can able to enhance the speed range.
Okay, thank you, sir.
Yeah.
Sir, one more question, sir.
Yeah,
So
please.
without monitoring the charging efficiency or power, output power, anything, without using any tools, how can I find out them, sir? The charging capacity.
Charging capacity, I'm not getting one second, please.
So without any tools or monitoring, without
Oh,
monitoring the output power or charging capacity range, how can we find out the charging position?
charging position means you are talking about SOC or
Yes, sir. SOC.
yeah, just to know, in a vehicle, you are having the battery management system. So in the
Okay.
battery management system, you are having the SOC estimation, right? So
Yes.
like our mobile, just you can, based on the usage, you are having the SOC of your battery on the top, right? So 80%, 30%, right? So this
Yes, sir.
information also collected by the another microcontroller which are available in the system, so that they will collect all the information. That information put it into the cloud or in a server. So
Okay.
based on that only, just you can able to schedule your vehicle for for a ride, or
Mhm.
you can schedule for vehicle to grid. That means for discharging. So during the time of use tariff, when you're using the time of use tariff, during the off peak hours, high peak, high or peak hours, the electricity price is higher. So that time you can use your battery energy to discharge, and you can sell your power at a higher cost. So in that way, you can able to make a profit out of it. So this
Okay.
information you need to gather, and you have to keep it in the local server, or you can keep it in the cloud to do the computation, further computations.
Okay, sir. Okay, sir. Uh, in wireless charging system, there is any possible in the charging pad or charging on the coil shapes? Anything is available, sir. Different coil shapes like that.
Yeah, it's available. So people are working on that, wireless charging for electric
Okay.
vehicles. So in
Okay.
that case, just we can have the different types of wireless charging techniques. So people used to say it's a resonant charging or LC charging and all. So in that case, we are having the different types of receiving and sending coils. So people also it's working on to enhance that enhance the efficiency of that wireless chargers. So earlier typical efficiency of these wireless chargers are around 60 to 70%. Now they are getting almost 80% of that efficiency. So that 80% of the efficiency also depending upon the we can say that distance between the receiver and receiving and sending coils.
Okay, sir. Okay.
Yeah.
What I recently faced on that means there is a different kind of different types of coils available in there, but in primary side and secondary sides are different. It's not available, sir. Like
No,
both are.
difference you can able to make it, no? So number of turns, right? So
Yes.
based on the number of turns, we can able to enhance the voltage and
Hmm.
current.
Okay.
So you can decide the number of turns when you are doing it your side. So you can decide the number of turns in the primary and secondary side.
Okay, sir. Okay, sir. Instead of turnings, somebody's using like a circular type, rectangular type, kind of types in both sides.
Hmm.
What I'm asking now, there is a different types in both the transmitting and receiving sides. A circular transmitter or a rectangular in receiver, kind of.
Yeah.
Is it
Both
working?
are having the merits and demerits, but now depending upon the requirement and the application, you have to choose this type of configurations. Type of
Okay,
configuration means the different types of windings.
okay, sir. Okay, sir.
Mm.
Okay, sir. Thank you so much, sir. Thank you,
Yeah.
sir.
Okay. Welcome, sir. Thank you.
Shall we wind up, sir?
Yeah, sure, ma'am. So happy to connect and happy to meet all.
Very thank you so much, sir.
Yeah, sure.